Ekene, your facilitator today, and we are going to be doing chemistry today. And what we are learning in chemistry today is what we call the blue bottle experiment. It's actually a reversible experiment. In chemistry, we have several kinds of reaction. You have the reversible reaction, you have the irreversible reaction. And we have some other forms of reaction, but today we are only talking about the reversible kind of reaction. So we are going to be making an experiment to show you what a reversible reaction is like. Okay, so we have just a couple of chemicals here. By my left here, I have glucose here. I have this is glucose, okay, glucose, and I have potassium hydroxide here. Potassium hydroxide. I have water, and I have methylene blue. This is an indicator that we use in redox reaction. Okay, so and here is the items here, just 4 items. Now I'm going to be taking 1 cup each of both. As you can see here, this is 1 cup of glucose in water, and my cup of glucose is somewhat synonymous to 10 grams of glucose. And the water I'm going to use is just going to be half of this bottle, which is like 50 ml. So I'll go ahead and take that. So alright, so I have about 10 grams in here of glucose. So I'm going to scoop another 10 grams of potassium hydroxide right here. Now potassium hydroxide is a crystal that is hygroscopic in nature. When I mean hygroscopic, I'm talking about that it has the ability to absorb water from the surrounding environment and to now dissolve in that water. Okay, so if you allow it, if you expose it too much in the atmosphere, it's going to absorb water and it becomes weakened, so to speak. So I'm going to put this here. These are also about 10 grams. I'm going to scoop it into the other bottle. Now this particular potassium hydroxide, it is caustic. It is caustic, and the reason is because of what I just explained, that it absorbs water. So if it touches your skin, what it's going to do is that it's going to suck out water from your skin. So you want to prevent yourself from being scalded by this particular chemical here. So whenever you are performing the experiment at home, you have to use safety gloves like this, and you have to, take your overalls to protect yourself. But it won't kill you, okay? It doesn't kill. And it is used basically in the soap manufacturing industry. Used to make soap. And glucose here, we all know what glucose is, a sweet substance that is an additive in most foods. So that's glucose for you. So right here, I have my chemicals all sorted out. About 10 grams of glucose in here, 10 grams of potassium hydroxide in here. So what I'm going to do, I'm going to add about 50 mils. 50 mils. I've actually done the maths before. So right now I'm just going to do it by eye. Just by my eyes, but I know the concentration. So right there. So this is about 50 mils. Now all I'm just gonna do is just to swell. I'll just swell. I'll swell. until it becomes clear. If I leave it down, it's become clear. And when you feel this particular solution is cold, it's cold. And the reason why it's cold is because it's actually absorbing heat from the environment. We call that endothermic reaction, which means it takes heat from the environment for it to dissolve. Okay, so that's exactly why it is cold. Now, likewise in this other bottle, I'll top it up to 50 mils too. So right there. And at the other hand, this particular one is hot. It's hot. So we'll call this an exothermic reaction, which means it gives off heat to the environment. Exo, that's outside. This one, endo, that's inside. Okay? And when I leave these two solutions to stand for a while, they're going to get clear. They're going to get clear. This one is somewhat chalky or hazy, while this one is now clear, all dissolved. So now this is my methylene blue. Before I put that in, I would need to mix these two solutions together. I need to mix them together. Okay, it's becoming clear, but I don't really need to wait for it. So I'll just put it in there. I'll put it in there. And one thing I love about chemistry is that when you mix two solutions together, they just mix up. You really don't need to, do so much, especially if they are liquids. You need to shake them if it's solute dissolving in solvent. But when they are two solvents mixing together, I need not shake it because everything just goes in there and they mix up. So having mixed up my solution here, I can divide it back into their bottles. So there, I have my mixture. So all I'm going to do is just put a little drops. I can measure that with this. I can measure that with this. So I'll put a little drop. Okay. So I've done that. Now what I did here, actually you could do this in the laboratory using dropper. You can use dropper to do this, or you can use the little pipette to do that. But right here I'm just improvising. So I'm going to swirl now, and you can see it's been leaked, absorbed. So I have a clear liquid here. So just watch what happens in a chip liquid. When I cock this solution back and I do this, you see that turns blue, and let it for a while and see what happens. Awesome. I'll do that again. Do that again. Blue. Watch what happens. Watch the transition. See? Awesome stuff. Awesome stuff. So awesome, right? So great. So the question is, what is actually happening? What's actually happening in this bottle? Because the point of chemistry is to be able to explain physical phenomenon. Anything that you see that happens physically has an explanation. So the point is, what actually happened in this bottle? Very simple. Now, I showed you earlier on some chemicals that we used. I talked about the glucose, I talked about the potassium hydroxide and the methylene blue. Each of them has their properties. For instance, glucose is what we call a reducing sugar. You may have heard about it before, reducing sugars. They are sugars that reduce some other substances by taking off oxygen from them. And in the end, they get oxidized. Okay? Now, which means they take off oxygen from compounds and add it to themselves. They get oxidized, that compound gets reduced. That's why they call them reducing agents. Okay? Now, and this methylene blue here is a dye. And all dyes have colors. There are several kinds of dyes. You have blue dyes, you have green dyes, yellow dyes, red dyes, and so on and so forth. But dyes have colors for a purpose. They have colors because they contain oxygen, basically. Oxygen is locked up within their matrix, and that gives them the color that they have, in combination with other chemical compounds that they have. So for this methylene blue, it's actually blue because it has lots of oxygen locked up in its chemical bonds. But this oxygen can actually be taken off of it. And that is exactly what our glucose did. When we mixed the glucose with the potassium hydroxide together, the glucose takes off the oxygen from this methylene blue, and it reduces the methylene blue from blue to colorless, becomes colorless. Okay? So, and when we leave it, everything settles down. The methylene blue takes back up oxygen from the space in the bottle. You know, there are oxygen locked up in that space. So the methylene blue takes off the oxygen from that space and becomes blue again. So what happens is that when we let it down, the glucose absorbs the oxygen from the methylene blue and the methylene blue disappears. Then when we shake it, the methylene blue takes off oxygen from the space and becomes blue back again. So that's exactly what happens there. So how about this? What does it do? That's the potassium hydroxide. Now, there is a reason why people study acids and bases. Acid and bases are compounds that you use to balance off things. They don't really take part in a reaction, so to speak. They are there to help a reaction to take place. They are not catalysts per se, but they are there to provide the environment for that reaction to really take place. I'll give you an instance. For instance, in a soft drink, all soft drink contains acids in the form of citric acid, propanoic acid, and the likes. These acids help in some way for the preservation of that particular food, that is the soft drink. And in another way, it helps to carry the organoleptic properties, things like the color, things like the sugar, those things. It helps it to be able to balance in that particular system. If there were no acids, these things will not give the appropriate taste and texture that it's supposed to give. That is why acids and bases are really, really important in food. They help the food to have a nice system to carry every other constituent that you are putting inside. So it's the same thing that this potassium hydroxide is doing in this solution. It is not really involved, so to speak, in this reaction. It only provides the opportunity for the methylene blue and the glucose to have a productive interaction, and for that redox reaction to take place. So that is that for this particular experiment. So you can reenact this experiment at home and have fun doing it. Thank you.